Now that we've remembered how to add and subtract with like denominators, we're going to review how to add and subtract with unlike denominators. So our first step here is we want to find our least common multiple, which is also known as our least common denominator. In order to do this, I would go ahead and find what multiples do they have in common. Let's see. Now, there's a couple different ways to do this. The way that I like is by factoring it, and then once you factor it completely, each of the numbers, you find out what do they have in common and then what's left over. So, for instance, 16 can be written as 2 times 2 times 2 times 2. 24 can be written as 2 times 2 times 2 times 3. So what do they have in common? They each have a 2, another 2, and another 2 in common. And then last but not least, they have a 3 that's not in common and a 2 that's not in common. Now this is the way that the textbook will usually show you. It has kind of like all of these lines and arrows and stuff like that. And then the idea is that you would multiply all of these numbers together. So 2 times 2 times 2, that's 8, times 2, that's 16, times 2, that's times 3, that's 48. So your least common multiple is 48. Now another way to show it, which I kind of like, and it works really nice when we're dealing with polynomials that are factored, is writing it out as each one in its own column. 2 times 2 times 2 times 2, 2 times 2 times 2 times 3. And I'm going to go like this. The first thing I want to do is say, well, what can I take out of both of these? Well, I can take out 3 2's. When I take out 3 2's, what do we have left here? A single 2. When I take out 3 2's, what do we have left here? A single 3. And then we can take each one of these out individually. And the idea is we're trying to make each column, I guess you could say, empty. So here we took out the 2. We're really dividing, so yeah, I'm going to keep that 1 there. Now I'm going to take out the 3. And then we multiply everything on this side together. 2 times 2 times 2 times 2 times 3, which again still gives us 48. So it just depends on how you want to do this. I'm going to be showing the polynomials like this so you can see it a little better. So now we need to say, okay, well, how do we make 16 into 48? Well, 16 already had 4 2's, 1, 2, 3, 4 2's, so we're missing a 3 from there, which means we need to take the 16 and times it by 3. And whatever we do to the bottom of a fraction, we do to the top of a fraction, times 3. Same thing for 24. We had 3 2's and a 3. So 3 2's and a 3. We're missing this 2 here, so I'm going to multiply the top and the bottom by 2. Now, of course, you could just take a calculator and say 48 divided by 16, what does that equal? 3. Okay, I need to multiply it by 3. 48 divided by 24, what does that equal? 2. Okay, I need to multiply it by 2. But it either way is perfectly fine. Once I find my common denominator, I'm going to rewrite my fractions to have common denominators. So that'll be 15 over 48 plus 18 over 48. And now we do what we did in the previous section by combining the numerators. 33 over 48 to write it as a single fraction. And now reduce. We can divide each one of these by 3 to give us 11 over 16. That is completely simplified, so that is our final answer. And whether we're adding or subtracting, the idea is the same. Write as fractions with common denominators, and then do our previous steps. So let's try one with an actual polynomial here. Okay, we will try x minus 4 over x squared plus 5x plus 6 plus 5x plus 6 over x squared plus 4x plus 3. So now our first step is we want to factor, just like we did here. We factored each of our denominators. So I want to factor our denominators here. So the factor of this denominator, x plus 2, x plus 3. The factor of this denominator here, x plus 3, x plus 1. And I'm going to do this. I'll explain how I got this in class. Well, how I learned this. One of my students originally with HPU, he was from Bulgaria, and he said, this is how we learned it when I was in school. And I thought that was so cool. I thought it was really understandable. So that's why I like to use it. So I'm going to find my least common denominator by writing each number in each denominator, in its own column. What do the two columns have in common? They each have an x plus 3, so that's what I'm going to take out, x plus 3. I don't have space there. What do I have left when I take out an x plus 3? I have an x plus 2 left in our first column and an x plus 1 left in our second column, and then we take each one out individually, x plus 2 and x plus 1. And now we would multiply all of it together, which is basically just saying x plus 3 plus x plus 2 plus x plus 1. So what are we missing? Get another color here. Well, we have x plus 3, we have x plus 2, we're missing an x plus 1. So I'm going to multiply this by x plus 1. Whatever we do to the bottom, we do to the top. X plus 1. And remember, this is a family here, so I'm going to put that in parentheses. I'm also going to put this in parentheses here. Okay. Here, in our second fraction, we have an x plus 3, we have an x plus 1, so we're missing an x plus 2. Now we're going to rewrite these fractions to have a common denominator. Now you'll notice in each of our numerators we have a binomial times a binomial and a binomial times a binomial. So we want to FOIL in each case. So here when we FOIL, first x times x, outside x times positive 1, inside negative 4 times x, and then last negative 4 times positive 1. That is going to give us x squared minus 3x minus 4 over our least common denominator of x plus 3 times x plus 2 times x plus 1. Then we write our second fraction. We go ahead and FOIL that as well. 5x squared plus 10 plus 6 plus 16x plus 12 over our common denominator of x plus 3 times x plus 2 times x plus 1. Now that we've written our fractions having common denominators, now we want to combine our numerators, which we have a lot going on here. So I am just going to work with the numerator here on the side. Well, I don't think I have enough space over there on the side. So I'm just kidding. I'm going to work with the denominator down on the bottom, the numerator down on the bottom here. We have x squared plus 3x minus 4 plus 5x squared plus 16x plus 12. Since we're adding the fractions, we can just add the like terms. X squared plus 5x squared gives us 6x squared. Negative 3x plus 16x gives us plus 13x, and negative 4 plus 12 gives us plus 8. And of course, we want to go ahead and factor that. Which gives us, let me do a little bit of work here. 48. Oh, we can't even factor that. So that is completely factored, if you will. So that's our numerator. 6x squared plus 13x plus 8 over the common denominator of x plus 3 times x plus 2 times x plus 1. I know that this one is pretty complicated. There's a lot of steps with it. I probably should have used a whole piece of paper instead of trying to scrunch it up.